All right, continuing our survey of the Animalia in the Bilateria, in the protostomes, in the non-molting protostomes, in our largest phylum, which are the mollusks, largest phylum of non-molting protostomes, I should say, second largest phylum of all animals. And we're getting into another class, which is the Cephalopoda. Cephalopoda means head, foot, because those are pretty much the only two things that are really noticeable on many of our cephalopods. They do have cephalization. They do have sensory organs accumulated in one part of the animal. All right, so first I'm going to draw. It's going to kind of look like an elongated arrow shape, but that's... And that's going to connect to the actual foot of the organism. This is going to be a squid. Now, squids have a mantle similar to what we saw in the gastropod, but the mantle doesn't secrete an external shell anymore. The mantle now only secretes a little chitinous stiffening structure inside, referred to as the pen, because it kind of looks like an old-timey like fountain pen when you dissect one of these animals. But that's it. It doesn't really have any hard parts other than its beak, which we're not going to draw. But one thing you may have been told as a youth is that one of the big differences between snails and squids is that squids have 10 tentacles and octopus have 8 tentacles. And that is not true. What squid do have, they have 2 tentacles. And that's what I'm drawing here, is they've got 2 tentacles, which are much longer than the rest of the appendages. So I'm trying to draw here. And we're going to draw some suckers, but the suckers are only going to be at the distal end. And that's going to be in contrast with, and I know these are just circles, but please accept for now that those are the suckers. Okay, so we've got 2 tentacles, which are substantially longer than the arms, which is what I'm about to draw. They're distal, which means farther away from the organism. So this would be proximal, this is distal. And then in here we're going to draw, I'm just going to kind of free ball. It's kind of hard to do it wrong, but we're going to draw 1, 2, 3, 4, 5. Ooh, that's kind of a... And then we'll kind of look behind. I'll loop one around. 6, 7, and put one more in back here. And these in here, we've got 8 arms with suckers along the entire length. I'll just write along entire length. So they extend all the way up to the beak. So we're just gonna, if you want to be more accurate, the suckers that are closer to the beak are going to be larger, and the further away you get from the mouth, the smaller they're going to get. Okay. I'm also sticking out from under the mantle is a structure called a siphon, and that siphon can be used to help give the animal a bit more propulsion when it's swimming. Squid tend to be a lot more benthic, meaning you can find them out in the open ocean. So they swim along with directionality, with intention in a particular direction, which is the advantage of having that internal pen to kind of stiffen the body to make it more hydrodynamic for better swimming. If they need a quick burst of speed, they can jet through the siphon. They can also use the siphon to release a cloud of ink, and they can actually ink in a number of different ways. They can either use ink plus mucus to form a kind of like a decoy, or they can use it just to kind of cloud the water and kind of make like a underwater smoke screen type dealio. All right, so that is your basic anatomy of a squid. We're going to contrast that with over here. We're just going to draw this shape here, arcing around, and now both of these animals have, and I didn't label them here, but I'll label them over here. Hopefully you remember that both of these animals have this amazing structure, which are image-forming eyes. Image-forming eyes. An octopus or a squid can actually see you, and their eyes can actually form an image, so they can tell that it is that you are not you are not me. You are you, and I am someone else, and your mother is somebody completely different. And an octopus or a squid could tell the difference. And it turns out that cephalopods are very intelligent organisms, and they can develop tastes. They like in preferences. They can develop feelings of like and dislike for individual people. This has been shown at different aquaria that some aquarists, the octopus will form a relationship with. Others, they will just not. They can dislike people, and they will, like, if they see that person, they will just squirt water at them whenever they see them and just be like, yeah, him, that's a hard no from me, guy. So yeah. And it used to be thought that these animals weren't that intelligent because they don't really have very large, sophisticated brains, but it turns out that the way that they can achieve this type of intelligence is by having their intelligence distributed throughout their entire nervous system. So each of the arms, and let's start drawing the arms since I'm just kind of blabbing on here. We're going to draw, hopefully you know how many there already are on an octopus. There are 0 tentacles, by the way. I'm just going to draw 1, 2, and again, it's kind of hard to draw it completely accurately or completely wrongly because they're just kind of, there's no bones there, so it's not like we need to make sure that we get any of the structures 100% correct. But there's 1, 2, 3, 4, and I'll put one more on the front side of the animal, extending up into, tucked under the mantle. So 1, 2, 3, 4, 5, and then we'll put another 6th one back here and a 7th one over there, and maybe have an 8th one that's kind of extending like this and like that. And 8. Octopus means 8 feet. And these are not feet, but rather arms that have suckers extending all the way down the length of the arm. And again, if we want to do it accurately, we would draw bigger circles at the proximal end, leading to smaller and smaller suckers at the distal end, the distal tips. They're typically 2 ranked, so they're in pairs. I'll just draw a few on this arm as well. So 8 arms, 0 tentacles on an octopus. So sticking out from that mantle, again, there's going to be a siphon. But fascinating animals are cephalopods. And there's been a lot of research that's come out about them recently, and a number of very cool documentaries, like My Octopus Teacher is one example. And the great tragedy with the cephalopods is that, at least with the octopodes, which is what one way of saying more than one octopus, that they don't live for a very long time. Like 3 to 5 years is really a very long life for an octopus. Often after they reproduce, they pass away. They do not care for their young, or their dying act might be to see that their eggs are will hatch, but they do not provide any care for their larvae. But the fact that they have these image-forming eyes, that is something that is by complete convergent evolution with the image-forming eyes that we find in vertebrates. It turns out that they're very similar in structure in terms of having like a cornea and a retina and a lens. Yeah, so that's something that we're finding within the protostomes, but we'll see it again in the deuterostomes, and not really anywhere else, although we will see compound eyes in the arthropods. Okay, so cephalopods include squid, octopus. How do you say more than one octopus? Octopodes is one accepted Greek pluralization. Octopi is not strictly speaking correct because octopus is a Greek word, comes from Greek word roots, and octopi would be giving a Latin pluralization. But you'll hear people say it anyway. And we hear people say octopi. You can just kind of grin and let them, live their best life. But octopodes is a more proper Greek pluralization. Anyway, that's cephalopods for you. Also includes cuttlefish, nautiluses, and a number of extinct forms like belemnites and ammonites and things like that.